Welcome friends and welcome to my series of video lectures on theory of structures. We are studying the topic of simple trusses, and in today's video we are going to continue with the problem on method of joints. The topic of simple trusses is related to the course outcome F. Evaluate axial forces in members of simple trusses. So we are studying a problem on method of joints. The problem is calculate member forces in given frame. This is the frame. Now, since the last two videos, we have calculated the member forces in four members: AB, AD, DE and BD. For that, we have solved the joint A and D. Now there are three members remaining: BC, DE, BE and CE. To solve to find out the member forces in these members, we will have to consider the new joints. So let us think of joint C. Our condition is that the joint should have maximum two unknown forces. If you look at C, there is one force CB, another force CE. The third force is a known force RC 7.5 kilonewton. Only three forces are there. So at C there are only two unknown forces, so we can take joint C. So let us take joint C for the study. So let us draw free body diagram of joint C. We can see that there are three forces acting at the joint C. This is 7.5 kilonewton already acting and its value is known. This is FCB and its direction is not known, so we will assume the direction like this away from the joint. This is force FCE. Its direction is also not known, so we will assume its direction like this. This angle is theta. This angle is already calculated in the earlier videos. So this is the free body diagram of joint C. Now we will analyze this joint. That means we will apply the conditions of equilibrium to this joint to find out the unknown forces. We can apply sigma fx equal to 0 and sigma fy equal to 0 in any order. In this joint, we will apply the sigma fy equal to 0 condition first. Why are we doing this change in the order? That you will come to know little in a minute. So let us apply the condition sigma fy equal to 0 to this joint C. There are total three forces. The first force is 7.5 kilonewton acting downwards, vertically downwards. So we will call it as minus 7.5. Then the second force is FCB, which is along x direction. So it does not have any y direction or y component. So this will not come in this equation. Now the third force is FCE. This is in inclined direction, neither along x nor along y. So it will have y component and x component. So its y component will be considered in this equation and it will be taken as FCE sine theta. Now the direction of this y component will be upwards. So that will be treated as positive. So this will be equated to 0 as sigma fy is equal to 0. So this equation is having only one unknown FCE. So we can get the answer directly. Therefore we get FCE. From this equation we get FCE equal to minus 8.38 kilonewton. Minus 8.38 kilonewton. The minus sign is indicative of that this direction of FCE, which we have assumed like this, is required to be changed. It is not this direction. This point we will consider while marking it in the diagram. Now the second is sigma fx equal to 0. This condition is going to give us the value of the other member force. So let us again apply this condition to all these three forces. The first force is 7.5 kN downwards, vertically downwards, so it does not have an x component. Second is FCB. FCB is already in y direction and it is towards left, so it will be minus FCB. Then the second force is this FCE and it is inclined, so it has got a y and x component. So its x component will be towards left and that component will be FCE cos theta. Since it is towards left, its sign will be minus. So this is to be equated to 0. So after we equate it to 0, we will substitute this value of FCE as minus 8.38 in this equation. So we will get minus FCB minus this FCE is minus 8.38 into cos theta equal to 0. And this will give us the value of FCB as plus 3.77 kilonewton. We have to note that the value of the angle theta is already calculated and that value is 63.43 degrees. Theta is already calculated as 63.43 degrees. So like this we have got the values of FCE and FCB. Let us write these values here. FCE is 8.38. We will show it here also. FCE, its direction is not like this, it is to be reversed. Look at joint C, its direction is reversed, so it will be towards the joint. So this is towards the joint, so its counterpart arrow here will be towards the joint E also, and the value will be 8.38. So we have shown. Now the arrows are away from each other, so it shows compression, as we have seen in the last video. Now the second is CB. The value of CB is plus 3.77. CB or BC 3.77. Member CB and BC of course are the same. Now the arrow tips will be drawn. This is plus 3.77, so the assumed direction of CB is correct. So it is away from the joint C. So we will have an arrow here, away from joint C. So the second arrow will come like this. And the magnitude will be 3.77. And since the arrow tips here are towards each other, facing each other, this indicates tension. So the nature of the force in this member is tensile or tension. So like this, we have got two more members calculated and only one member is now remaining. So only one member remains to be known now. So for that, we will have to try one more joint. We will have to try one more joint. That member is BE. Look at the member BE. Yes. So this BE has got one joint at E, one joint at B. So we can take the example of joint E or joint B. So let us take joint E. In this, let us take joint E. Look at joint E. At EBC, 1, 2, 3, 4. 4 forces are seen. this 10 kilonewton is a known force, 8.38 towards the joint is a known force, 2.61 towards the away from the joint is a known force, and this EB or BE is the only unknown force. There is only one unknown force, so we will calculate it by applying conditions of equilibrium. Let us draw the free body diagram of joint E here itself. So there is a horizontal force. This is joint E. There is horizontal force of 10 kilonewton. Then secondly, there is an inclined force of 8.38. Then there is another inclined force which is acting away. This is unknown force. We are showing it as that it is acting away as an assumption. So it is FEB. And there is a x direction force here. Its direction is known. It is 2.61. 2.61 kilonewton. So this is the situation at joint E. Now we know that the angle here is phi. If we look here again we get the angle phi. In the previous videos we have already calculated that angle phi. So we will now apply the conditions of equilibrium to this joint. We will apply the conditions of equilibrium to this joint. You can apply only one condition of equilibrium because only one unknown is to be calculated. Now we will apply the condition sigma fx equal to 0. I will write it here. Sigma fx equal to 0. Sigma fx equal to 0. So this condition will look at all the forces here in x direction. The first one is 10 kilonewton towards right. So it is plus 10. The second force is 2.61 towards left. So this is 2.61 minus 2.61. Then this 8.38 kilonewton is an inclined force. So it will have an x component and y component. Its x component will be towards left. So it will be minus 8.38. And it will be sine of phi. Then there is FEB. This FEB is also inclined. So it will have x component and y component. So x component of FEB will be towards left again. So it will be minus FEB into again sine phi, and this will be equal to 0. I hope you have understood this equation. You have to concentrate properly and do these values, put these values. So you will find that only one unknown is here, FEB. That's all. This is the equation. So when you do the calculations, you will get FEB equal to minus 14.21, 14.21 kilonewton. This is the answer you get. So this is the member force in the member EB, this EB. So what is the meaning of this minus sign? Minus sign means that this FEB, this is the direction we have assumed. This direction is wrong. It should have been towards the joint. So we will show in this diagram that FEB towards the joint and not away from the joint. So its counterpart comes here. right? And the value is 14.21. I am not writing that value there because that will become very clumsy. So this is in the table, it will be BE 14.21. 14.21. Now let us do the final task of deciding whether it is tension or compression. So look at the member EB. You find these red arrows on this member. These two arrows are away from each other. They are not towards each other. Since they are away from each other, they are indicating compression. So this will be compression. So friends, we have come to the end of this problem. Our task was calculate member forces in given frame. There were 7 members and we have calculated the forces in all the 7 members, and we have also decided their nature, whether it is tension or compression, and we have used method of joints to calculate these member forces. So with this we have completed this problem. I hope you have understood this problem. The key to master this technique is to solve many problems. I will recommend that you should solve at least 5 such problems independently and see that your answers tally with the given final answers. This will give you a good confidence about this method. So that was a problem on method of joints for a simply supported frame. I hope you have understood the problem. Because this was the first problem, this problem may appear to be lengthy. But as you have enough practice with the problem solved, you will understand that it is not so lengthy problem. So I will recommend that you should have good practice of these problems, and then this will be a good technique for you. So goodbye till the next video.